today we're going to be using our calculators again, but now we're going to be using them to solve equations, find zeros, find solutions of a polynomial. Basically, this is just a technique to approximate answers to an equation, which is usable the entire year. So anytime the directions are to solve an equation and you don't know how to solve the equation, this is a technique for solving an equation. Alright, first thing is you want the equation you're solving to equal 0. Alright, so if it already equals 0, you're ready to go. If it doesn't equal 0, you want to make it equal 0. There's other ways to do it where it doesn't equal 0, that's just a little more complicated. So it's easier when it equals 0. So this one's already ready to go. You type in what you see. And I'm going to caution you again, like I did yesterday, when you're dealing with power functions, you're going to hit the caret key to get up to the third power. You got to get out of the power level before you type the rest of the function. Again, it's more of a nuisance than anything because it'll be pretty obvious when you see the entire function up in the power level that you know you typed it in wrong, but then you got to delete everything and retype it. So 18x cubed, and again I hit the caret 3 to get up to x cubed, and now I'm up here, so I have to hit the right arrow to get back down, and then I can type the rest of it, 3x squared. The x squared button immediately just puts the squared and puts you back down to minus 61x, and then plus 10. Now, I'm going to make an assumption that we don't have any idea what the answer is for this, right? I mean, basically, we're in a situation here where there's no reason we should know the answer to that equation off the top of our head. So, usually, in the calculus book, most of your answers lie between negative 10 and 10, usually. Occasionally, you'll get one that, I mean, maybe the answer is 72,000, I mean, something like that. But usually, they're pretty reasonable between negative 10 and 10. So if you just go to a Zoom standard, Zoom 6, it will graph, and it's cubic function. We graphed cubic functions yesterday. Whoa. You can see that it's obviously not fully on the screen. Okay, now if our purpose was to graph this thing, now we're going to start finagling with the window a little bit. Looks like I probably need to stay between negative 3 and 3 on x, and I might have to go really high and really low on y to get this thing to fit in here. But my purpose here is not to find a graph, it's not to graph it, it's to find the answers. Alright, and let me just drag this over here real quick. When you're looking at a graph, the answers when the function itself equals 0 happen when the function itself crosses the x-axis. Okay? The x-axis equation is y equals 0. This is what y is, so it equals 0 when it touches the x-axis. So we're trying to find those points specifically. Now I can see that this one's close to negative 2, this one's close to 0, this one's close to positive 2. Alright? That's all you need is close. You don't have to be exactly right. If you know enough to be close, you're ready to go. If you want to get a better view of it though, I can go back to my window, and let's say go from negative 3 to 3 on the x-axis. Again, I'm going to keep y the same because I don't care about the top and the bottom of this problem. Hit graph again, and then I get a more detailed view of the graph. That one looks like it's right on negative 2. That looks like to be about 0.2 maybe, and maybe about 1.6 or 7. About 1.8 somewhere in there, I don't know. So let me just get this out of here. So let's just take this one. So again, I'm looking at this picture, and my goal here is to find the solutions. Alright, the function I'm going to use to find the solutions is under the calc, which is above trace, so we hit second, trace, and that brings me to calc. And we're trying to find where the function equals 0, which you can see here is choice 2. Alright, now, it wants 3 pieces of information from you. It wants a left bound, a right bound, and a guess. You're going to input all 3 of those things. I type the numbers. You can also cursor left and right to go along the graph, but I actually type in numbers myself. So what it's looking for left bound is something like here's, obviously we're going to guess negative 2 for that one, right? So left of negative 2 would be, let's say, negative 3, and right would be negative 1. So for left bound, I'm putting negative 3. For right bound, I'm going to put 1. And for my guess, I'm going to put negative 2. So it goes like this. Left bound, negative 3. Something less than you think the answer is. Right bound, negative 1. Something bigger than you think the answer is. Guess, negative 2. Something you think the answer is close to. And it happens to be exactly negative 2. So I'm going to write down x equals -2. That's one of my solutions. Now it does say correct to 2 decimal places. If it happens to be exactly a number, don't worry about putting the decimals in. If it ends up being some long, drawn-out decimal expansion, give me a couple decimal places around it. Okay. Next answer looks to be about, what do you think, 0.2, 0.1, somewhere in there?
Yeah.
All right. So Tyler, what would be a good left bound?
Left bound?
Left bound, if we think 0.2 is the answer.
0.1.
How about something smaller?
Smaller?
Yeah.
0.01.
How about 0?
0.
Pick whole numbers. All right.
Okay.
If make your guess a decimal, that's fine. But let's say the answer. Let's say it's 0.09, and you pick 0.1.
Yeah.
All right. I can obviously see 0 is left of it.
Yeah.
All right. So you want to make an obvious pick, because if you tell the calculator, let's say, I don't know.
So you can put 0, -1, -2.
Well, yeah, basically. But let's just say, I don't know. Let's pretend the answer is x equals 0.03. Okay, it's not, but let's say it is.
Okay.
But you think, oh, I'm going to guess left bound is 0.1, right bound is 0.5, and guess is 0.3, let's say. Let's say you did that. All right, the answer is 0.03. There's no answer between these two numbers, so it'll be an error. All right? So when you're looking at this and trying to make this guess, this left bound, right bound thing, pick something that's obviously not the answer.
Okay.
All right, so again, 0.1 might be the answer. I don't know. But 0 definitely
So
is.
guess something you don't.
Yeah, guess something obviously not the answer. So left bound is 0. What's something obviously not the answer to the right?
Second trace. 1 second.
Anybody? Something obviously not right to the right.
1.
1? Okay. And what do we want to guess?
2.
And the guess really doesn't matter as long as it's not bigger than 1 or less than 0 at this point. If I say left bound 0, right bound 1, guess 53, the calculator doesn't like that. So pick between 0 and 1 when you guess. If I pick 0.9999, it'll find the answer. But let's just guess 0.2. It finds the answer quicker that way. 0.166666667, so that'd be 0.17 if we're going 2 decimal places.
And there's going to be 3 answers?
Yep, every time it crosses counts as an answer, so we got to find all the answers. All right, so Chris, give me a guess for a left bound for the third answer.
Left bound.
So here it is.
1.
All right, very good. Left bound would be 1. Tyler, right bound for this last answer over here. 2. Very well. And let's go with Renee. What do you want to guess? Left and right bounds are 1 and 2.
For the third line?
Mm-hmm.
1.80.
Perfect. All right, and we type that in, and we end up with 1.67. All right.
I'm so proud of you.
So we found our solutions. On your homework, the calculator is doing all the work for you. So when you get homework problems like this, there's not going to be a lot of work to be shown. What I'm going to verify is that you got all the correct answers. So when I grade this assignment, it's not going to be graded on did you show your work, it's going to be are all the answers correct. All right, so, and just make sure you find all of them. Know that a cubic function can have 3 answers. If you found 3 answers, you're done. If it was to the 5th power, there can be up to 5 answers. Okay. Usually if they aren't between -10 and 10, when you start dealing with polynomials to high powers, you usually find them all. They have to have really, really, really tiny coefficients to get answers outside the -10 to 10 range.